This is video 1-2, Intro to the Periodic Table and Classification of Matter. You need out the periodic table, the blank one that I gave you, and also some blank sheets of paper because a lot of the things in here are not in your notes, so you need to copy them down. So, first thing, on your blank periodic table, above each one of these columns, write in these numbers, 1A, 2A, 3A, etc., all the way up to 8A. Okay, so from the first day of class, you should have seen we also should have some numbers in here also. This should have had +1, +2 above that column, +3, plus or minus 4, -3, etc. So you should still have those in there, plus also write in these. Also, let's number these columns here too. We got, or these rows, row 1, row 2, row 3, row 4, row 5, row 6, and row 7. Okay. And next thing you want to do is this staircase right here. You want to duplicate that on your periodic table. Okay. Start drawing a nice dark line. Make sure you start on the left side of this first one right here in the third column. Go down and over, down and over, down and over, etc. And right in this little staircase. Okay. Now, start labeling these things. All of these vertical columns that we have here, they have a special name for them. These are called groups or families. The horizontal rows, these also have names for them. These are called periods. Okay. Now, we numbered these before. 1, 2, 3, 4, 5, 6, 7 rows or 7 periods. These two down here, and on your blank periodic table, it shows you that this one is actually going up here, and this one is actually going up here. So these are not rows 8 and 9. These are just part of row 6 and part of row 7. Okay, so do not label this 8 and 9. This is actually 6 and 7. Okay, now, that little staircase that we put in there, what's the purpose of it? Well, it basically breaks up the periodic table into a couple different types of elements. Oh, one more thing. These, where you see the blue boxes, put some X's in those boxes on your periodic table. Okay. You notice they're all touching the staircase, but this one right here, do not put an X in there because that's not a blue box. Okay. And you'll see why that one is not included in a second. Okay. So, what's the purpose of that staircase? It breaks the periodic table up into two main groups of elements. The metals on the left side and non-metals on the right side. So everything to the left of the staircase is considered to be a metal. Okay, now, what were these X's supposed to be? Okay, well, these X's, these elements have special names for them. They actually fall into a category called metalloids. Okay, so your X's are basically the metalloid elements. Hey, now, this whole big middle section here that we skipped over, these elements make up their own little group, and they're called the transition metals. Okay? Now, remember, everything to the left side of this staircase are things that we call metals, but things like Na, sodium, Ca, calcium, when you hear those names, you don't normally think of them as metals. You normally think of things as metals as being things like copper, or iron, or gold. Okay, so most of the things that we consider to be metals are actually in this family called the transition metals. Okay, now, column 8A has its own special name, and these are known as the noble gases. Okay, the bottom two rows, the top row is called the lanthanides. The next row, these are called the actinides. Okay, these two rows together make up a group called the rare earth, or sometimes called the inner transition metals. Okay, why are these the inner transition metals? Because these sets of elements actually appear right here and right here. So in other words, this whole set of elements right here to the right of it is basically broken off and actually appears all the way at the end down here. Okay. Now, why the name lanthanides and actinides when this one right here is called cerium and this one right here is called thorium? Well, this cerium actually comes right after La, which is known as lanthanum. And the thorium actually comes after this element right here, which is known as actinium. So that's where the names of these elements actually come from, even though lanthanum and actinium aren't really considered part of the rare earth metals. Okay, now you need out a blank sheet of paper and start taking down these extra notes because we're going to putting in more information on some of these things on the periodic table. So 1A, just like column 8A had a special name for the noble gases, column 1A also has its own name, the alkali metals. Now, be careful with that name because in column 2A, these are called the alkaline earth metals. Don't mix them up. Don't call column 1A alkaline metals. Column 2A is called the alkaline earth, and it has to have both of those names in it. Column 3A, called the boron family. 4A is the carbon family, 5A is the nitrogen family, 6A is the oxygen family. If you look on your periodic table, the one that actually has the elements in it, the top of column 3A is boron. Top of column 4A is the element carbon, top of 5A is nitrogen, top of 6A is oxygen. So it should be pretty simple for you to remember those names. Column 7A also has its own special name. It's not called the fluorine family, even though that's the first element. Column 7A is known as the halogens. Okay, so column 1A, 2A, and the last two columns, 7A and 8A. All four of these have their own special names, so make sure you remember what those names are. Okay, now, why do we break up the periodic table with the metals and nonmetals? Well, the elements, if they're metals, have certain characteristics to them. Okay. Metals are shiny. You can look at them, you go, oh, well, that's a metallic element simply because of the way it looks. It has a shiny luster to it. They're good conductors of heat and electricity. They're malleable. If you take a piece of metal and you hit it with a hammer, it doesn't shatter, it just flattens out. You keep hitting it, it gets flatter and flatter and flatter. Take a piece of metal that's kind of in the shape of a cylinder and you start pulling on it. It doesn't break apart. It stretches out, gets longer and longer and longer, and eventually you end up with a wire. This is known as being ductile. You can also take a piece of metal, bend it, and it won't break. So it has what's known as a high tensile strength. Okay, examples will be things like copper. Non-metals, non-metallic elements. What are their characteristics? Okay, well, they all tend to have low melting points. Some of them, their melting points are so low, not only do they melt, they also boil, which means they're gases. They have a dull luster to them if they're in the solid phase. They're poor conductors of heat and electricity, okay, and they're brittle. And if you take a look at these characteristics, these tend to be the opposites of non-metals, non-metallic characteristics. Okay, example would be something like phosphorus. Okay, now, the metalloids. Why do they have their own little category? Well, because they border the metals and the non-metals, they have the characteristics of both the metals and the non-metals. So, they are all going to be solids. They will be semiconductors of electricity. Semiconductors, you find them, this term semiconductors, used in things like computer chips. What makes up computer chips? Silicon, which is one of the metalloids. Okay. And they will tend to have a little bit of malleability. They're going to be less malleable than metals, but more malleable than non-metals. The noble gases. Okay. These are generally unreactive. Sometimes these are all, as the name implies, they're all gases. Okay. Sometimes these were also called the inert gases, spelled this way. Inert basically means that it doesn't do anything. It's non-reactive. Now, this is kind of a misleading name because some of them do react. But helium and neon cannot form compounds, so they truly are inert gases. Next thing, copy this down, classification of matter. So you need kind of a big sheet because we have a little chart right here. Okay, matter, we know what that is. We already talked about the definition of it. It can be broken up into two basic categories. Matter is either going to be classified as a mixture or pure substance. These two categories can also be broken up into two subcategories. So in other words, any type of matter is either going to be a homogeneous mixture, a heterogeneous mixture, a compound, or an element. It has to fall under one of these four categories. Okay. So, what is a mixture? What's the difference between a mixture and a pure substance? Well, if a substance is a mixture, it has to be a blend of two or more substances, and each one of those substances retains its own identity and properties. In other words, it's a physical combination. If you make a mixture of salt and water, you still have to have salt and you still have to have water. They cannot change their their chemical properties. Okay. And the compositions can vary also. Whenever you make a saltwater mixture, there's no one way to make salt water. You can use different amounts of salt, different amounts of water, but it's still a saltwater mixture. So, what's the difference between homogeneous and heterogeneous mixtures? A homogeneous mixture, it's uniform in composition. Okay. The only difference is how well these substances, the mixtures, are put together. If it's uniform in composition, it has to be on the atomic level. Okay. You cannot just simply say, well, I'm going to take some salt and sugar and make a mixture, and I'll make it homogeneous because I'll put a piece of salt next to a piece of sugar, a piece of salt, a piece of sugar. Because the salt crystals and the sugar crystals aren't exactly the same in size, it's still not going to be uniform. Okay. These are also known as solutions. Now, what's a heterogeneous mixture? Okay. Simply, they're not uniform in composition. If you take some salt and some water and you make a try and make a salt water mixture, if the salt just sits on the bottom, that is not homogeneous because you have a lot more salt on the bottom and very little at the top of your mixture, so that would make it heterogeneous. Now, if you were to mix it so that the salt basically was completely evenly dispersed, then it would be homogeneous. But otherwise, if it is not uniform, it's going to be a heterogeneous mixture. Pure substances. What's a pure substance? It is fixed in composition. There's only one type of particle that makes up this substance. Okay. Every sample, as a result, has to have exactly the same composition or percentage of elements. For example, if you took water, regardless of how big or how small your sample size was, let's see, 1/9 of it is always going to be hydrogen by mass, and 8/9 of it will always be oxygen by mass, and it doesn't matter how big or how small the sample size is. Okay. So, pure substances, they can only be either compounds or elements. Now, a compound can be broken down into two or more simpler substances or elements by a chemical change. That's the only way you can break it down. If you can put it through a physical change, then it wasn't a compound. Okay? And as a result, the substances that are formed after you break up a compound are going to be different than what you started with. Elements are the simplest form of matter. Okay? They cannot be broken down further by chemical methods. So here's your review question. Okay, what would salt water be classified as? An element, compound, pure substance, heterogeneous mixture, or homogeneous mixture? Remember your letter and record it on the review question online.